Okay, cool. So this is looking pretty good. So we have a lot of stuff in here. We have deposit collateral and mint DSC. So people can mint our stablecoin by depositing collateral. People can just straight up deposit collateral. People can then redeem their collateral for the DSC that they minted. They can just straight up redeem collateral. They can just straight up mint DSC so long as they didn't break the health factor. They can burn DSC to go help their health factor. I don't think this line will ever hit. We've got to do a couple of more things here. Most importantly, we got to do this liquidate function. So this liquidate function is kind of the key thing that holds this whole system together. If we do start nearing under collateralization, we need someone to start liquidating positions, removing those positions. We need somebody to basically call, redeem and burn for you if your health factor becomes too poor, right? Because the worst thing that would happen is, let's say there's $100 worth of ETH backing $50 worth of DSC, and then the price of ETH tanks to $20, right? $20 of ETH backing $50 of DSC. Well, now the DSC isn't worth $1, right? The DSC then is going to be worth, whatever 20 over 50 is. So we can't let this happen, right? We need to make sure we liquidate people's positions. We remove people's positions in the system if the price of the collateral tanks, okay? And this is where liquidation comes in. So we say if someone is almost under collateralized, we will pay you to liquidate them. We have kind of this gamified incentive system here where people can get basically free money for removing other people's positions in the protocol. So in this situation up here, as the price is going down, let's say the price goes down to $75, backing $50 of DSC, this is way lower than our 50% threshold. So what we're going to do is we're going to let liquidator take this $75 backing, takes the $75 backing and pays off the $50 DSC and burns off the 50 DSC. So we're going to have somebody able to take their money in exchange for them making sure our protocol stays collateralized. So that's what this liquidate function is going to do. So first off, they're going to be able to choose the collateral, the user that they want to liquidate, and the UN256 debt to cover. And they'll be able to track the users and their positions by listening to these events that we've been emitting, which is exciting. We're going to definitely want a lot of NAT spec for this. So at param, collateral is going to be the collateral to liquidate, or better yet, the ERC20 address, collateral address to liquidate from the user at param user, the user who has broken the health factor. Their health factor should be below min health factor. At param debt to cover is going to be the amount of DSC you want to burn to improve the user's health factor. Yeah, we're going to add a lot of at notices here. At notice, you can partially liquidate a user. Just so long as you improve their health factor, that's all we care about. At notice, you will get a liquidation bonus for taking the user's funds, right? We want to incentivize them to actually do this, right? If we say, okay, cool, you'll get the $50 back for paying off the $50 debt, it's going to be hard to incentivize people to do that. But if we say you get all $75 and all you have to do is pay back 50, then that's going to be a bonus that they should be able to take to incentivize them to do this. At notice, this function working assumes the protocol will be roughly 200% over collateralized in order for this to work. Why? Well, because in this scenario, if this drops down to $20 backing $50 of DSC, and if I pay back the 50 DSC and I get $20, well, then I'm not going to do that. I'm not going to pay $50 to get back 20. So this whole system only works if the system is always over collateralized. The only way we can give liquidation bonuses is if we're over collateralized. So the only way we can incentivize people to liquidate poor users is if we are over collateralized. So we could say at notice, a known bug would be if the protocol were 100% or less collateralized, then we wouldn't be able to incentivize the liquidators. And then we would just say, like, for example, if the price of the collateral plummeted before anyone could be liquidated. So hopefully this makes a lot of sense. If this doesn't make sense, you know what to do. Ask ChatGPT, ask in the discussions forum, Google it, use the resources that you have to your advantage. Yes? Yes. Okay, good. So debt to cover. We probably want to do more than 0. Very lame if they did just 0. So we're going to do more than 0 here. We're going to be moving tokens around. So we're going to do non-reentrant as well. Maybe we'll do some more modifiers, but that looks pretty good to me right now. So now, what do we need to do? Well, we need to do a bunch of stuff here. Well, we first need to check health factor of the user, right? Is this user even liquidatable, right? Remember, we want to do follows CEI, checks, effects, interactions, right? We always want to follow CEI. So we should do some more checks here because we should only liquidate people who are liquidatable. So first thing we should do, UNT256, starting user health factor equals underscore health factor of the user, right? Because we have this health factor function, which gets that health factor. And what we can say, and let's put this above. And now we'll say if the starting user health factor is greater than or equal to the min health factor, which what's our min health factor again? 1. Actually, it should be 1 E18. And we're definitely going to write some tests to make sure this is correct. So 1 E18, because we're using our precision here. What else are we doing health factor? Why don't we write tests elsewhere? Revert if health factor is broken. Oh, I guess we haven't tested this yet. Well, I guess we're going to be testing it very soon. Make sure that that health factor bit is right. So if the starting user health factor is greater than or equal to the health factor, then we revert, right? Revert DSC engine underscore health factor, okay, right? Health factor is fine. Got a new error. Let's go to the top, scroll down, error, health factor, okay. Back, go back down here. Remember, I'm doing control minus to go back. It might be something else depending on your setup. So let's do some thinking. So now we have their starting health factor. What do we want to do? We want to burn their DSC debt, right? We want to reduce the amount of DSC they have and take their collateral. We want to remove them from the system basically, right? So how do we do that? Let's say they have $140 of ETH deposited and $100 of DSC. With a setup like this, their health factor should be below what it currently is. What we could do is we can say, okay, we're going to cover. So this is what bad user, this bad user has. That means we could say, okay, we're going to cover debt to cover. It's going to equal that $100. And we need to pay back $100. So we're going to have to get a UNT256 collateral or token amount from debt covered. So we need to figure out, okay, if we're covering $100 of debt, $100 of DSC equals how much ETH? So we're going to pay back $100 of debt, and how much ETH is that? Okay, how much ETH is that? So we're going to get the token amount of debt colored, the ETH basically, equals, and we're going to have to do some pricing stuff. We're going to have to say it equals get token amount from USD. So we're going to add the collateral and the debt to cover. So we're going to figure out, okay, how much of this token are we going to get, right? We're going to cover $100 worth of debt. How much in ETH or whatever collateral token is $100 worth of debt? So we're going to have to create a new function, get token amount from USD. This is going to be a public view function. So we're going to scroll all the way down here, public and external view functions. Function get token amount from USD, and we're going to pass an address token or collateral, UNT 256 USD amount in way. This will be a public view returns UNT 256, and we're gonna have to do some price feed stuff. So we're gonna need, what are we gonna need to do? We're gonna need to get the price of ETH or the token, and then we're gonna have to say, okay, so if the pricing is dollar per ETH, and we have ETH, how do we get the dollar? Well, if we do some math here, let's say it's $2,000 of ETH, and we have $1,000, right? How much ETH is that? We're going to do the 1,000 divided by 2,000, which is going to equal 0.5 ETH, right? So we're going to do this number divided by this number. The amount, the USD amount in way divided by the price. And that's how we're going to get this token or collateral amount from the USD amount. So we'll say aggregator v3 interface price feed equals aggregator v3 interface of S price feed of token. Oh, wow. It even filled in a lot of this for me. That's great. Yes, this looks right. So we're going to get the price feed of the token and get call the latest round data on it to get the price here. And then we're just going to do this right here. So we're going to say the amount USD in way divided by the price, or UNT56 price. Is this the full story? No, absolutely not, because we should always multiply first. So we're going to do this times our precision. Then we can divide by the price. But is that the whole story? No, because the price has 8 decimal places and we need it to have 18. So we're going to do additional feed precision like this. Does that look right? So if we have, let's say we have 10 E18 for amount in way, we're timesing that by 1 E18 like this. We're saying divide that by the price. Let's say the price is $2,000, $2,000 E8 times the 1 E10, the additional piece here. This looks pretty correct. Do we need anything else? Let's even just pull out the calculator, right? So 10, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 times 1, 1, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 divided by 2, 1, 2, 3, 2,000, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 1, 2, 3, 4, 5, 6, 7, 8 equals this number, which is probably a half, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Is that right? 1, 2, 3, 4, 5, 6, 7, 8, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. 8, 9. 0 point. Is that right? Oh, because it's $10, duh. Yes, this is right. I was like, I thought we did $1,000, but this is $10. Yes. Okay, cool. That looks good to me. Great. And then obviously we're going to test this soon to make sure that it is right. So we have this function where we get the token amount from the USD. So we're saying, hey, we're going to cover $100 of your debt or something like that. How much ETH is $100 worth of your debt? Maybe it's, if the price is $2,000, we would do 100 divided by 2,000, 0.05 right there, right? So this is going to be something like 0.05 ETH or whatever it is, right? Cool. So we have how much ETH we need to take away from their collateral as a reward for paying back this DSC. But additionally, we also want to, and give them a 10% bonus, right? Because we want to incentivize them. If it's just a 1-for-1, they're not going to want to do this. So let's say we're going to give them a 10% bonus. So we are giving the liquidator $110 of WETH for 100 DSC, whatever $110 of WETH is going to be. We should implement a feature to liquidate in the event the protocol is insolvent. We're not going to add that in yet though, but we should probably add something like that. And then add sweep extra amounts into a treasury, but we're not going to add either one of those. So don't worry if that's confusing. Don't worry about that. We're not even going to implement that anyways. So we'll say UN256 bonus collateral equals this token amount debt covered times some liquidation bonus that we haven't defined yet, although we're going to do 10%, divided by 100, but I hate these floating numbers, so we're going to do something better than 100. We're going to do liquidator precision, which is 100, and we'll do unit 256, private, constant, liquidator bonus equals shun bonus. It's going to be 10. Be like, this means a 10% bonus. And since it's going to be 10 divided by 100, that's going to be 10%. Let's go back down. Liquidation bonus divided by liquidation precision. So the bonus collateral is going to be 10%. So let's say it was 0.05 ETH. We're going to multiply that by 0.1, right? Because we're going to multiply first and then divide to get 0.005 ETH. So as a total, or that's not quite right. It's going to be 0.005. 0.05 times 0.1 equals yes. So that means they're going to get 0.055. Is that right? I think that's right. Why am I being bad at math? Time 0.1. Yes. Okay, cool. Great. So that's what they're going to get, this bonus collateral. We got to add the bonus collateral to the actual collateral. So we're going to say like you went to 256 total collateral to redeem equals token amount from debt covered plus bonus collateral, like that. And now we need to redeem this amount of collateral for whoever's calling the liquidate function, right? We need to redeem that collateral. And then we also need to burn the DSC from this user as well. So we need to give them the collateral and burn the DSC that they're covering with their debt to cover.